Hey, and welcome to the Healthcare AI hands-on broadcast. I'm your host, Mike Mastanduno today, and I'm joined by Mike Levy and Yannick Van Hoel. I hope I said that right. It's the first time I've pronounced your name. Which is funny to hear. But regardless, we've got a great show today. So you can watch on our website or on the YouTube channel, and we'd love to have your comments and participate in our discussion. We're going to be hands off the code, but we're going to be having a more lively discussion about machine learning 101. So it should be really interesting. We've got some good questions from users. We've got some good news articles we found this week to add to that discussion. And we'd love to get your input on what you think. So, you can feel free to chat in the YouTube channel. We've got our computers out only so we can monitor that. So, all three of us will be able to pounce on that single response that we get. But you can subscribe to the channel for notifications. We'd love to have you join the Slack channel. We've got a pretty healthy community on Slack nowadays with a lot of good discussion about the latest and greatest in machine learning, healthcare, techniques, R, classes, whatever you think you might want to see, it's in there. And so, yeah, we'd love to see you there. And then as a final plug, we'd love to meet you in person. We're running a 2-day workshop as part of the Healthcare Analytics Summit here in Salt Lake City. And so if you feel like you want to take the next steps and kind of go through statistical analysis and machine learning and specifically healthcare AI, data prep, the man's right here, and he'll give you a great demonstration. So we'd love to see you at that. So with that, I think we can head over to questions with the users.
Yeah, so we got a couple of questions this week. The first one is, have you used the diabetes readmission dataset from UCI? And more generally, can you talk about datasets from UCI?
And it's so funny that question came in because I just used that dataset to teach a class up in Minneapolis last week.
And the class was a dry run of the Healthcare Analytics Summit class,
It was,
right?
as a matter of fact.
How did it go?
It went well. I think we're not going to use this data set again because this data set is hard to make predictions on. So this is a data set from 130 different hospitals over a decade of everyone who was admitted for diabetes, and the outcome variable is whether the patient is readmitted within 30 days, after 30 days, or not at all. So in this class, I used that to teach machine learning, classification problems, whether a patient is readmitted or not. And it turns out that, some data sets just have a lot of noise in them. And in this data set, whether a patient is readmitted or not doesn't seem to be strongly determined by the variables that are on offer in the data set. So it's a good data set to learn machine learning on. There are a lot of features there, a lot of different kinds of features, but not, as far as we could tell, not a lot of predictive power in the data set.
Thanks. Another question, what kind of data is in a no-show data set and how do you process it? So can either of you tell us what is a no-show data set to begin with? What sort of problem is that?
Well, we did some work on no-shows, which is to calculate the probability that a patient might no-show an exam or not show up to their appointment. And the idea being that, maybe you can prioritize reminder calls, or you could use that information to double book slots so that the day stays full. But you're getting into that murky nature of the way airlines overbook flights. Nobody likes waiting at the doctor's office, but you definitely see differences based on the data in no-show rates. And so, there's categorical and continuous variables in there. So categorical ones would be something like the day of the week is a pretty good indication. People are more likely to skip near weekends. I guess it's easier to forget, or who knows. And then, all the things like continuous variables. I can't think of one off the top of my head, but
The age of the patient.
There we go. Yes, age of the patient is important too. And how do you deal with those? So, we have to do the normal things for each type, like clean up the null values. We have to transform the dates of the appointment date into days of the week, or time of the year, month of the year, and you can do any sort of standardization or normalization things to make sure everything's on the same scale. a lot of the same techniques that we've been over in previous broadcasts on feature engineering can be applied there. So we don't have any code to post, which is I think what the original question asked in the part 2, but the code remains pretty similar to the example code, and it's all about how you engineer those features.
And I'll just point out, Kaggle.com, which is one of the anchors for data science and machine learning on the internet, they had a competition around predicting no-show for appointments.
There is that no-show data set.
So there's a data set there, and you can look at the efforts that other people have put into making those predictions there. That'd be a great place to get started.
Excellent. Any other questions this week, or?
I think that's it.
All right, that's it. Well, we've got a couple of news articles. Mike, do you want to summarize them?
Yeah, let's get into the news. So there was an op-ed at Nature this week. Nature, the big peer-reviewed publication, they published some op-eds. And there was one by Cliver Sherlock titled "The DeepMind Debacle Demands Dialogue on Data." I'm not sure why they couldn't start any of the title words with letters other than D, but it's an interesting article all the same. The gist of it is that what's the public organization? And so this public organization in England provided a bunch of data to DeepMind, which is this artificial intelligence subsidiary of Google that does great AI work, but they didn't think very hard about data privacy and about what data was being handed over. And they created something of a backlash, which is a shame, the article says, because we need more discussion about data privacy issues and about how data is handled as AI and machine learning push further into healthcare and other industries.
Yeah, and it really is. It's such an impediment to getting the field into healthcare. One of the reasons we're doing this broadcast is to try and do that. But we are just up against that very real challenge that data is not available to organizations other than hospitals or companies that manage hospitals' data.
Yeah, those are really hard problems.
So you basically have to be either a data scientist working at the hospital, or you have to be, working on a sample data set that isn't really going to be useful in the real setting.
I thought it was really interesting. This article quoted a survey that showed that 54% of Brits had low trust in internet companies' propensity to use their data appropriately. So folks don't trust that their data is going to be used appropriately, and when it's as important as healthcare data, that's a real problem.
Yeah, it certainly is. Although the approval ratings are still higher than most politicians.
Well, that's an easy bar.
And what was the other article?
So there's another article on healthcare IT news titled, "With Machine Learning and AI in Healthcare, Can You Speak the Language?" And this wasn't about writing Python or R code. It was about what these terms that we use so commonly actually mean. What does AI mean? What does machine learning mean? And can we come to consensus on these terms?
So Yannick, what's your definition for machine learning?
So my definition for machine learning is it's a fancy term for applied statistics.
He's a mathematician.
But it's very, very useful applied statistics. So I think maybe machine learning, you get paid a little bit more than if you're doing something called statistics.
Note to all your statistics grad students out there.
I would define machine learning as using data to learn patterns and make inferences about future data of the same type.
Yeah, it tends to be a little more predictive oriented
Yeah.
than statistics.
And often I'd say it's doing things that are hard to do by just setting rules. That sort of, maybe a classic example is recognizing handwritten digits. You and I are very good at telling a 1 from a 2 and a 2 from a 7. But if you try and write down exactly what makes a 1 a 1, a 2 a 2, and a 7 a 7, you're going to have pages and pages and still not get it right. And machine learning is sort of a way to use information get information from the data to make decisions that sometimes we would find easy and sometimes we don't find easy, but sort of get complicated information into a useful form.
So if that's machine learning, what do you guys think of as AI, as artificial intelligence?
Well, I've always thought of AI as being more advanced. Things like what you see in movies, like the Iron Man movies. Those are infuriating. Or, I guess you'd say like translation services and self-driving cars and things that seem to be a much more complex machine learning system of, several different models all interacting together to come to a common, I guess, output. That in my mind is more what AI is.
Yeah, I would agree that AI, for me, I think of it as somehow being a little bit more complicated, a little bit more advanced, but definitely very much related. And I think you can probably find people who will say AI is a subset of machine learning, and this article seems to say the opposite. That machine learning is a part of AI. So I don't think there's a clear consensus.
But it does underscore the point of the article.
Yeah.
That we
Exactly.
mean different things by these terms, and
Yeah.
we need to come to consensus.
So, we'd love to hear how you define machine learning or AI, or if you just want to take our definition, that's fine too. We're all right with that. But it's about transparency, and the way it really applies to healthcare is that if you don't know what's actually being done, if one clinician is saying, Mrs. Jones, we used artificial intelligence to diagnose your kidney disease, and another physician is saying, hey, we used a regression algorithm to do the same thing. Mrs. Jones isn't going to know what either of those things are, but they have ramifications across the health system.
And she may be wondering, why are you not using AI? Why are you not using machine learning? And just a lot of confusion can ensue.
So there are growing pains for the industry, for sure, but worthwhile. So we'll get into our main event here, which is, as promised, it's a Machine Learning 101. And we've had a lot of comments from viewers and, people we've interacted with through the Slack channel or the chat. Basically want to know what machine learning is. And they're not even, a lot of times they're non-technical, but they're unsure of, what is machine learning? What am I going to get from it? So we wanted to address that in the broadcast this week. And, the first point we wanted to cover is what is machine learning? And Yannick and I kind of already gave our definitions. Mike, did you have anything to add to that?
Yeah, I liked what you guys had to say. Something along the lines of using computers to find patterns in data. And I think it emphasizes prediction, right?
Yeah.
Where often statistical models try to explain the relationship between variables. Machine learning is about predicting outcomes.
Okay, so in statistics and analysis, maybe you're going to be looking backwards in time for the most
Typically,
part.
yeah.
But in machine learning, you're typically looking forwards in time. Okay, so we're trying to predict the future, but does that mean we can do it? Like, what is machine learning? What can it really do?
So I'd say, yeah, you can predict the future as long as the future doesn't look too different from the past. That we're really using old data to get information about what's the most likely thing that will happen, and if the old data looks a lot like the new data, then things you say about the old data will probably be relevant for the new data. And so it's sort of looking back to look forward.
Got it. So kind of, looking through the patient medical history of all the patients in the hospital, you can find kind of similar attributes and patterns and apply them to current patients, which is what we're doing. So I guess what kind of machine learning problems are there then? And I know we've done a broadcast on use cases and the different types, but we'll kind of cover them, reiterate them here. There's two main types of machine learning. There's a classification and regression.
And I guess we could even step back further and say, unsupervised learning versus supervised learning.
Yeah.
And most of the examples that we're interested in, it's supervised learning. We're interested in making predictions, though that may change, that we're adding some clustering into the package.
So just to be really explicit,
Yeah.
so clustering problems or unsupervised problems, there's not an outcome variable of interest. You just want to group the data into groups that make sense, that come together.
Mm-hmm.
With supervised problems, you have some outcome of interest, like will a patient be readmitted, or what's a patient's fasting glucose, and you try to tie that to other aspects of the data.
And so then what about classification and regression?
So those would be in a supervised learning situation that, well, it depends what is the thing you want to predict. Is it a continuous, basically is it a number? If I want to predict how long someone's going to be in the hospital, the length of stay. That can be any number of days or hours. I don't want to set specific values for what it can be beforehand, versus I might just be interested in, will a patient be readmitted? That's sort of a yes or no question, and I'm just looking for yes or no, and that would be in the classification setting. So we tend to, when we do the split classification versus regression, we're talking mostly about what the output is going to be. Is it a number that can be within reason, any number you want, or is it one of two fixed categories or possibly more that we can also deal with? For example, in readmission, we can deal with not readmitted, readmitted within 30 days, readmitted after 30 days was one of the data sets we were looking at. So.
Well, we had someone ask in the chat, how coupled is the data set to, I assume, the type of machine learning? And, that comes down to really what your question you're trying to answer is. So in the case of length of stay, which is a great example of a regression data set, because you could predict this patient will be here 5 days, 6 days, 7 days. You might want to turn that into a more simple problem, which is just, will this patient stay greater than 5 days? In which case you have total control over whether you want to do a classification or a regression analysis, and then all those algorithms that kind of fit the different types.
And then I guess there are some situations where it really is determined by the data set, that if you're predicting diabetes or not diabetes, you probably are not going to do it as, are you predicting 30% diabetes, 35% diabetes? That doesn't make much sense. So there are some data sets where the problem is obviously going to be a classification or obviously a regression problem, but in many cases, like the example that Mike gave, you have some choice in the matter.
And so that'll depend on the use case, right? Often some question of clinical significance might be a numeric response, in which case you want to use a regression problem. But if what you're interested in is predicting whether that patient is going to be back in the hospital or not, then the classification algorithm might be more useful to the end user.
Yeah. Great. So, I think that gives a good picture of kind of what machine learning is and what it does. It's important to keep in mind, though, that it's just a piece of a much larger picture. So how does machine learning fit into context? Are we going to just replace the hospital with machine learning? Is it going to turn into a server farm?
Instead of doctors, we'll have segways with iPads.
Yeah, exactly.
Like in Arrested Development.
Yeah. So is that going to happen, or what's more closer to reality?
These are tools for caregivers and administrators to use, right? So they have input from patients and from their coworkers and from the environment, and this is one more input that they can bring to improve their decision making. Right?
Yeah. So a while ago, we had this great article in the New Yorker about AI in medicine, and I would look it up. It's by Mukherjee, the author of The Emperor of All Maladies. In the New Yorker. I forget the exact title, but it's a fantastic article. And he comes to the conclusion that AI is going to be a really great tool, or machine learning, however you want to define it. It's going to be a great tool, but it's never going to go away. Doctors are never going to go away. It's a decision support thing. And so he just does a really nice job of articulating that point. And so like Mike said, we have patient data, we have lab results, you have past data, and it's kind of the it's the pinnacle of bringing the analysis into the hospital. So being able to use that data to affect day-to-day decisions and improve the lives, right? Of your patients, like using the past data. You don't have to keep it in your head. It's given to you as this is the thing you should focus on.
And it can do that at a highly granular level, right? It can do that at the level of an individual patient or an individual practice or whatever.
Yeah, so that's really cool.
Yeah. So
I think that's a pretty good definition, unless the chat is unhappy with that. We'll move on to kind of a big picture, 30,000-foot view of how you implement machine learning in the hospital. So we've always kind of used the same 5-step process or so, and I don't see a reason to deviate from that right now. So, the first step is always going to be to find a relevant question that's well suited to machine learning. So, length of stay, picking a above long length of stay classification of that while the patient is in the hospital. If you can use that to reduce length of stay for patients, that's a good use case. It's going to save money. It's going to make, presumably it's going to get patients home faster. And as long as their readmission risk isn't going up, another model, you could use that as a way to, to prioritize who gets to go home first, or who needs extra care so that they can go home on time. So find a relevant question. And then the next step is always feature engineering, which is kind of taking that data that comes from all these different places. And Yannick, you had a really good idea for kind of how to define feature engineering.
I think this
was that Mike?
Mike's idea. You want to get it into it. Well, I'll steal it. You want to make sure that you have a nice rectangle. That your data is in a nice rectangle with no holes. So you don't want a block of Swiss cheese. You want things nicely organized into a table. You want to deal with missing values. If you're missing information, do you want to not include those rows? Do you want to make your best guess? Do you want to use information to fill in those holes? But you somehow need to end up with a nicely formatted table that you can feed to your model, or use the algorithms on.
Yeah, and so like you're going to be using literature and clinicians to kind of talk about what data is likely to help answer your question that you've come up with, and then the technical concerns of preparing that data to put into a model. Yeah. So how do you choose a model?
Well, healthcare.ai has some tools to help you choose the best model, actually, for your given problem. Once you have your data in a rectangle, you can try out a bunch of different models and see which performs the best.
And that's a big departure from kind of the statistical methods, right? Where you have to be really careful about what's in the data and what's going on with the model. Machine learning it seems more like it's just try it and see if it looks good,
But there's a lot of stuff going on behind the scenes.
Yeah.
So there's many of the things that you would have done the old way with statistics is being done. It's just not being done by you. That Mike has programmed in a lot of the tricky things, and
so if they don't
you
work,
don't have to
that's
see
why.
the mess.
Okay, and then once you have that model, you can kind of go through this evaluation process where, again, we have a different broadcast on this topic too, if you want to go into more details. But if you're running a regression problem, you're going to be looking at root mean squared error or mean squared error or some kind of transformation of those.
Yeah.
You'll be probably plotting the predicted values versus the real values for a little test set and kind of looking visually at how they look. If you're in a classification, you'll be looking at accuracy, but if you have imbalanced classes, which you often do, accuracy is going to be a bad metric to use, and you'll want to use something like area under an ROC curve, or you want to do precision recall, or PR curves even. So, model evaluation, that's kind of the step that you say, hey, I've got a great model, this is how well it performs. And then the only thing left after that is presentation. So how do you, and this is just like picking a question, this is an often overlooked part of the process because, you think, hey, I got a great accuracy, I'm done. But, in healthcare, you're not interested in building a good model, you're interested in improving healthcare outcomes. And so there's some step that has to happen between generating probabilities and getting them into the hands of the people who can use them to actually improve things.
So a canonical example might be you have a classification problem, your model outputs a probability, say that the patient is going to get a central line infection. What do you want to surface to the caregiver? Do you want to give them a yes-no call on whether it's going to happen, or a probability that it might happen, or some sort of visualization? Do you want to integrate that into the EMR?
Yeah, because you behind the keyboard, you can't do anything about their central line infection, right?
That's right.
You just have. That's right. You have to be able to give it to the physician, and the physician has to kind of know what to do with that.
Although you might be able to provide suggestions.
Yeah, and that's another hot topic. The better your suggestions can be, the more transparency you'll have, and the more trust you'll build in that model. So that's another thing that we've been working on over here. Yannick's doing a lot of work on that front. and we're not going to let him go until he does, until he finishes.
And maybe it should be noted this is not sort of a linear process always, that you start by finding a relevant question. Maybe you decide I want to work on length of stay, and it seems reasonable to predict length of stay greater than 5 days, less than 5 days. You go, you talk to doctors and clinicians and figure out what are sort of reasonable predictors for whether a patient's going to be in the hospital for longer than that. And then you play around with it and realize maybe the question wasn't posed correctly. Maybe I'm not interested in 5 days, but 7 days, or maybe I'm missing a variable, and you sort of go back and forth until you get a good model. And at the very end, well, if it didn't work out, you can start over. You've at least learned something about what didn't go right, and you can hopefully feed those into your next attempt.
So we just have a couple more points to cover. We're almost out of time, so I want to make sure we get to those points. And then there's some good questions from the users too, so we can try and get through those. But basically, the last couple of points is the caveat section, or the except, So we want to make sure that you remember, the model is only as good as the data that you can give it. I think a wise person once said, you can't predict a person's height based on the amount of ice cream they eat as a child. Maybe their weight, but probably not their height. So, remember that your model is only as good as the data you're feeding to it. And that's always going to be the case, whether you're training it or whether you're using that model to make predictions. If the data is really high quality but really different from the training data, that model's not going to be useful anymore, just because of the difference. Which kind of leads me into the next point, which is that you can only make predictions on that same population. So, if you trained a great model and then, for a hospital in the Northwest, and then you bring it to the Southeast, chances are it's not going to work, because it needs to be trained on the same data it's going to be using to evaluate, which I think is you see machine learning marketplaces, and you can buy a model for readmissions, or and that's not going to work.
I didn't know you could do that. That's terrifying.
You can, yeah, it's crazy.
Don't do that.
Okay. And then the final thing is that, this is all decision support. It's not magic. We're not trying to replace clinicians. We're not trying to, we say prioritize resources a lot, but, we're never going to be saying, oh, your case isn't important because the machine learning said it's not important. So, a doctor's not going to see your case. It might mean that a doctor doesn't see your case until a little later, but that's only because there's somebody much sicker or more impactable ahead of you.
And the output is always going to be probabilistic, right?
Yeah.
Our models can say that things are likely to happen or unlikely to happen, but they're never going to see the future.
So one question we had is anything about the state of ML right now that worries you? I'd say, yeah, buying a model off a marketplace and then putting it into your health system would be something that worries me.
Yeah, and I think the reason that raised my eyebrow is that I think there's so much hype, so much excitement around machine learning and artificial intelligence right now that a lot of folks are diving in without necessarily understanding all the details, or having folks that they can consult with to make sure that the details are right. Mm-hmm. And you can easily be led astray that way.
Yeah, and really knowing the limitations is, you have to understand it before you can use it. Yeah. Though it is easy to to set up one of those auto ML pipelines like healthcare.ai, and just get a model and throw it into production, and maybe it's not doing what you think it's doing, but that's because you missed the use case. We had
and if I can just add on to that, we have tools to evaluate models in production. So if things aren't going well, we have ways to evaluate that and ways to revisit the model training process.
And we had a user kind of ask, how do you pick the question that you're going to answer? Should that come from a process improvement group that's going to go and test the efficacy of the tool? And I would say ideally it would be. Mm-hmm. It would be great to know exactly what your model is doing for outcomes. That's not always the case. A lot of times it's a single clinician gets really excited about a readmission risk model, and then that's what you end up building. But I think we're moving towards the direction where people are seeing the gains that can be made from machine learning, and starting to work from the top down. for the most impact?
Yeah, I think that individual had a follow-up question about using a full factorial research design to measure the change in outcomes that the tool provides to the healthcare provider. Have we seen that implemented? Are people doing experiments on the improvements that models produce?
I don't think we've really seen that. I mean, it's a bit of a gray area because you want to be able to show that the model's creating improvement, but you don't want to have to reserve. If you're really if you suspect that it will, and everyone's really excited about using it, it feels bad to kind of withhold that model from one set of patients, but not from another.
Yeah.
And then there's a lot of other concerns about, well, you could use a different hospital or you could use different time frames, but then you get different differences in the data sets that kind of might make that analysis a bit more murky. So it's definitely a difficult question right now for healthcare. But thanks for all the great questions. I think we'll go through these and either answer them on Slack or next week we'll hopefully be able to pull these up. Unless you guys have anything else to add on the ML 101, I think that's probably the show.
Be good.
All right. Well, thanks for watching and hope to see you next week.
Thank you for joining us today. Remember to like, share, and subscribe, comment below, and click the links below to join our Slack channel and our Healthcare AI community.